Hello everyone, today we'll be looking at the quick solutions to the chemistry section of All India AIATS Test Series JEE Advanced 2020 Test 4A Paper 2 Code C and D. So let's start with the first section, students. So students, the first section contains 8 questions. The answers to these questions are in the form of single digit integer. Okay. Let us look at question number 21, students. Consider the following reaction. So we've been given a reaction sequence, students. The examiner seems to be interested in the mass of oxygen which is present in the 1 mole of T. It is further mentioned that T is an aromatic compound, and if the mass of oxygen present is x grams, we have to comment on the value of x by 6. Okay. So students, if we try and figure out the reaction sequence which is given to us, okay, we can clearly see that there is an ester group present, students, and when the ester is hydrolyzed, it will lead to the generation of the carboxylic acid and the alcohol over here. Okay. So if we talk about the benzene containing compound P, students, it is mentioned to us that T is an aromatic compound, so we have to deal with the benzene containing compound only. Okay, so if we talk about P, students, the structure of P is going to be this. Okay, now students, it is mentioned to us that this compound is allowed to react with KOH. Okay, so if we talk about the reaction of this compound with KOH, students, the KOH is going to extract this acidic hydrogen and then it will lead to the generation of an anion over here. So students, this acidic H will be extracted and the alkoxide ion will be generated, which can now attack intramolecularly, showing the aromatic nucleophilic substitution reaction, as there are two nitro groups present at the ortho and the para position to the leaving group. Okay, so this alkoxide which is generated, it will attack at this position and make the Cl leave. So if we talk about the compound Q which is formed now, students, the compound Q is going to be this compound. Okay, so the labeled oxygen will be retained in the compound. So this is Q, students. Now if we talk about the reaction of Q with TnHCl in excess, so both these nitro groups will be converted into amine group, students, and then it is allowed to further react with the NaNO2HCl. So diazotization is going to take place. So this NO2 will be first converted into NH2, and then the NH2 will again be converted into N2 plus. Okay, and then the compound S will be formed, students, and now when this compound S is allowed to react with H3PO2, this N2 plus will be substituted by hydrogens. Okay, so if we talk about the final compound which is formed, students, these groups will be replaced by hydrogen. Okay, so we're going to have a benzene ring, and then adjacent to the benzene ring there will be another 6-membered ring containing oxygen. Okay, so the oxygen will be labeled, it is oxygen 18. Okay, so this is the final compound T which is formed in the above reaction sequence, students. And if we talk about the mass of oxygen present, there is only one oxygen present and its mass is equal to 18 grams. So the value of X is equal to 18. Now since we have to report the value of X by 6, it has to be reported as 3. So students, the answer to question number 21 is 3. Let us look at the next question now. Question number 22. A compound X containing CHNO is unreactive towards sodium. It does add bromine. It does not react with the Schiff's reagent. On reaction with one equivalent of Hi, it gives the compound KNL. L is iodine containing compound. K undergoes tautomerism to form Z, which can undergo aldol condensation as well as iodoform reaction. If the minimum molar mass of the compound X is M, then the value of M by 11.6 is equal to. Okay. So students, a number of different reactions for the compound X have been given to us. So we just have to tabulate them and then figure out the whole reaction sequence. Okay. So we start with the compound X, students. The compound X, it contains CHNO only. Okay. It is mentioned to us that it is unreactive towards sodium. So it does not react with sodium. So there is no reaction. It does add bromine. Okay. So this gives the bromine water test positive. Okay. If we talk about the third one, it does not react with the Schiff's reagent. It means that it is not a carbonyl compound. Okay. It did not react with Na. It meant it does not contain acidic hydrogen. Okay. If you talk about the further information which is given to us, students, it tells us that on reaction with one equivalent of Hi, it gives the compound KNL. So students, X compound is most likely going to be an ether. So X is going to be an ether. So it is mentioned to us that X reacts with one equivalent of HI to form the compounds K and L. Okay. It is mentioned to us that the L is the iodine containing compound. So L, it contains iodine. It is further mentioned to us that K undergoes tautomerism to form Z. So K can tautomerize to give Z, and this Z can show aldol as well as the iodoform reaction. Okay. So students, if we talk about the compound Z has to show aldol as well as the iodoform test. Okay. So if we talk about the species which has the minimum molar mass and satisfies both these conditions, so it has to be acetaldehyde, students. So Z has to be CH3CHO. So Z is CH3CHO. And students, it is mentioned to us that Z was obtained by the tautomerism of K. So students, the K has to be an enol. So if we try and figure out the structure of K, students, it has to be an enol. So CH2CH, and then there will be an OH group which is present, students. Okay. So this is the compound K. Okay. Now if we talk about L, students, this L also has to have the minimum molar mass as per the question. So it has to be CH3I. Okay, so L is CH3I. So if we talk about the ether which was originally taken, students, so it has to be a combination of these two compounds. Okay, so it has to be a methyl vinyl ether. So we have the compound X now. It is a methyl vinyl ether. Okay. And if we talk about the molecular formula or the molar mass, students, its molecular formula is going to be C3H6O. There is 1 Du. And if we talk about the molar mass, it will come out to be equal to 58. Okay. So now, students, we have to report the value of M by 11.6. So M when divided by 11.6, it gives us a value equal to 5. So students, the answer to question number 22 has to be reported as 5. Let us look at the next question now. Question number 23. For the reaction shown below, the concentration of R is increased 4 times, then the rate of reaction will be increased by n times. We have to comment on the value of n. Okay. So if we look at the reaction which is given to us, students, we have a tertiary alkyl iodide which is allowed to react with ETOH in excess. Okay. So students, here solvolysis is going to take place, and the iodine being a good leaving group, it will leave, leading to the generation of a tertiary carbocation which contains 6 alpha hydrogens, and then the conjugation with the benzene ring as well. Students, the carbocation going to be formed is very, very stable. So the reaction will proceed by the SN1 mechanism. Okay. So it is unimolecular. So the rate will be depicted by K into concentration of the reactant, which is R raised to the power 1. Okay. So we can clearly see that if the concentration of R is increased 4 times, then the rate will also become 4 times, as it is a first order reaction. So students, the answer to question number 23 has to be marked as 4. Let us look at the next question now. Let us look at question number 24. How many of the given polymers are the chain growth polymers? Students, if we talk about the chain growth polymers, they are also called as addition polymers. So these polymers, they polymerize by the free radical mechanism. So if we talk about the polymers which are given to us, we have polythene. Polythene has to be an answer. Nylon 6,6, it is a polyamide, it is a condensation polymer. Terylene is a polyester, it is also a condensation polymer. We have Teflon. Teflon is polytetrafluoroethene. So this is also an addition polymer. We have neoprene. Neoprene is polyisoprene. So polyisoprene is also a chain growth polymer. We have PHBV, which is again an ester. So it has to be a condensation polymer. We have Novolac. Novolac is also a condensation polymer. We have polyacrylonitrile. So this is also an addition polymer, students. If we talk about Buna S consists of butadiene and styrene. So both of them, they co-polymerize by the addition polymerization. And if we talk about PVC, this is polyvinyl chloride. So this also polymerizes by the addition polymerization. So if you look at the total number of compounds or the polymers which polymerize by the addition polymerization, so we have a total of 6 compounds. So students, the answer to question number 24 has to be marked as 6. Let us look at the next question now. Let us look at question number 25, students. A mixture of two aromatic organic compounds A and B was separated by dissolving in chloroform followed by the extraction with aqueous KOH solution. So first A and B were both dissolved in chloroform and then there was extraction using KOH. So it is mentioned that the organic layer containing compound A, when heated with alcoholic KOH, gave a foul smelling compound C. The alkaline aqueous layer, on the other hand, when heated with CO2 under a high pressure of 100 atmosphere and then acidified, gave compound D. So students, it's obvious to us that when A and B were both dissolved in chloroform layer and then they were extracted with KOH, so the compound A, it was insoluble in KOH and it was present in the organic layer. So the compound A was further allowed to react with alcoholic KOH. So when this compound A was allowed to react with alcoholic KOH, it gave us a foul smelling compound C. So compound C was formed, which is foul smelling. Its formula given to us is C7H5N. Okay, its degree of unsaturation comes out to be equal to 6. So if we look at the reagent system which is present, students, there is alcoholic KOH and then there is the CHCl3, which is the chloroform present in the organic layer. So students, if we look at the foul smelling compound C, it has to be an isocyanide. So it is isocyanide. And if you look at the formula or the DU, it has to be PHNC, which must mean that the compound A is aniline. So the compound A has to be aniline. So it does not react with KOH. Its hydrogen is not very acidic to be dissolved in KOH. So we have the compound A now, students. The compound A is aniline. It is further given to us that the alkaline aqueous layer, so the alkaline aqueous layer, it will contain the compound B. So it was heated with CO2 under high pressure. So it was allowed to react with CO2 under high pressure. It formed a compound D. So the formula of D is given to us. It is C7H6O3. And it is mentioned to us that the compound D, when it is acetylated, it gives us aspirin. So students, it is mentioned that D upon acetylation, it gives us aspirin. So students, if we talk about the structure of aspirin, so aspirin is this structure, students. So this is formed upon acetylation. So it must mean that the compound D is salicylic acid. And now if we talk about the compound B, which was present in the alkaline layer, students, so it has to be phenol. So phenol on reaction with CO2 gives us salicylic acid, which on further acetylation gives us aspirin. So students, the compound B is phenol and it is present in the form of the phenoxide ion in the alkaline aqueous layer. So this is the compound B now. This was D. So the examiner is interested in the difference in the number of sp2 hybridized carbon atoms in compound C and D. So if we talk about compound C, students, compound C was the isocyanide. So it has 6 sp2 hybridized carbon atoms. Whereas if we talk about the compound D, it has 7 sp2 hybridized carbon atoms. So there is an additional sp2 hybridized carbon atom which is present in the COH group, whereas the additional carbon is sp hybridized in the isocyanide which was formed. So students, there is a difference of only 1 carbon atom which is sp2 hybridized. So the answer to question number 25 has to be reported as 1. Let us look at the next question now. Let us look at question number 26 now, students. Consider the following reaction sequence and the label steps 1 to 7. Okay, so we've been given a sequence of reaction, students, from step 1 to step 7. In the above reaction sequence, which step leads to the formation of the wrong product or intermediate? So it is mentioned to us that we have to assume that all the predicted products in a particular step are the major product of that step. Okay, so we are starting with this compound. It is first allowed to react with NaI in acetone. Okay, so we have a chloride and then the alkyl chloride is going to react with NaI in acetone, showing us the Finkelstein reaction, students, in which the Cl will be replaced by I via SN2 mechanism. Okay, so students, the first reaction step is correct. There is an SN2 attack in which I minus replaces Cl minus. Okay, so first step is correct. Now if we talk about the second reaction now, students, in the second reaction we have the reaction of the alkyl iodide with ammonia. So this ammonia is going to make another SN2 attack and make this iodide leave. So this is also correctly specified, students. There will be formation of amine at the position where the iodide was located. So this step is also correct, students. If we talk about the third step now, in which the amine is allowed to react with HNO2. So students, this HNO2 is going to convert this NH2 into N2 positive and make it leave. So there will be the generation of a carbocation, students. So the carbocation will be formed at this place itself. So the third step is also correct. Now students, if we talk about the next conversion which is given to us, so it is mentioned that the H2O is going to attack at this carbocation itself. So this is the incorrect step, students. This carbocation which is formed, it can undergo ring expansion. So there will be ring expansion happening in this step, students. So the step number 4 is not correctly represented. Now if we talk about the fifth one, so for this reaction, students, we have to assume that this is the reactant as mentioned to us in the question. So it does not matter if it is a wrong product which is shown over here, but then further subsequent reaction we have to assume that this is the reactant. Okay, so now students, when this reactant is allowed to react with PCC, the primary alcohol which is present, it will convert into an aldehyde, which is correctly represented. Now if we talk about the sixth step, so we have the attack of hydrazine. So we are going to get the formation of hydrazone, which is correctly represented, students. And now if we talk about the reaction of the hydrazone with the KOH in glycol, so it is going to cause Wolff-Kishner reduction, students. So the group will leave and there will be the formation of CH3 over here. Okay, so the seventh step is also correct, students. So out of these given 7 reactions, only the reaction labeled as number 4 is not correct. So students, for this question we have to mark the answer as 4. Let us look at the next question now. Question number 27. An optically active alcohol C7H12O absorbs 2 moles of H2 per mole of P upon catalytic hydrogenation and gives a product B which is also optically active. So let us try and tabulate the information. So we have P, which is C7H12O. Its degree of unsaturation is equal to 2. So it is mentioned to us that it reacts with 2 moles of H2. So there is no cyclic ring present in this structure. Okay. So it is further mentioned to us that P on reaction with 2 moles of H2, it forms the compound B, which is also optically active. Okay. So we have B, which has to be C7H16O. Okay. So it is given to us that both P as well as B are optically active. Okay. It is mentioned to us that the compound B is resistant to oxidation by CrO3. So if the compound B is resistant to oxidation by CrO3, it means that it has to be a tertiary alcohol. Okay, so the information is given to us that the compound B is a tertiary alcohol. Okay, it is further mentioned that the B molecule has one ethyl group as a substituent. Okay, so it has one ethyl group as a substituent. Okay. When compound P is treated with concentrated H2SO4 and heated, the total number of pi electrons which are participating in resonance is. Okay. So students, if we talk about the compound B now, okay, so compound B has to be optically active and it also has to be a tertiary alcohol. Okay, so we can have the chiral carbon, so it has to be tertiary, so we have 2 OH on the carbon and then there is one ethyl group. Okay, CH2, CH3. Okay, now students, we have already used up 3 carbons. We need further of 4 more carbons. Okay, so the only possibility is there is a methyl group as a substituent and then there is a propyl group as a substituent or its derivative. So this is most likely the compound B, which was the optically active tertiary alcohol, students. Okay, now students, if you talk about the compound P which was initially taken, so that also has to be an optically active alcohol. Okay, so students, we have 2 double bonds, so we can have a double bond over here in the ethyl group as well as a double bond here in the propyl group. Okay, so we can have cases where the double bond can be present over here or over here. Okay, so we can just draw the structure. So these are the two compounds or the two structures which are possible for the compound P. Okay. Now when this compound P is allowed to react with concentrated H2SO4 in presence of heat. So when this is allowed to react with concentrated H2SO4 in presence of heat, students, both of these compounds are going to give us the same product, which will be the product having the extended conjugation. Okay, so there are a total of 6 carbons in the main chain, and then there is a substituent at the 4th position. Okay, so there is extended conjugation in the system, and this is the product which is finally formed after the reaction with concentrated H2SO4 and heat. Okay, so if we talk about the number of pi electrons which are present in conjugation over here, students, we can clearly see that the answer to question number 27 has to be reported as 6. Okay, let us look at the next question now. Question number 28. Consider the double helical structure of DNA. A short domain of a nitrogen base pairs on the 2 strands of DNA are given. Okay, so we have been given a strand of DNA, students. We have to comment on the total number of hydrogen bonds involved in between the given 3 nitrogen base pairs. Okay, so if we talk about these bases which are given to us in DNA, students, we know that A is bonded with T and then C is bonded with G. Okay, so in between A and T there are 2 hydrogen bonds, and in between C and G there are 3 hydrogen bonds. Okay, so we have a total of 2 AT pairs and 1 CG pair. Okay, so if we talk about the total number of hydrogen bonds present, students, it has to be equal to 7. So students, the answer to question number 28 has to be marked as 7. Okay, let us look at the next question now.